In this simple electronics experiment, I'm testing a 2.7 volt 10 farad supercapacitor to demonstrate how it can store and release energy. Supercapacitors are unique because they can charge and discharge much faster than regular batteries and are often used in energy storage applications. To begin, I'll use a digital multimeter to measure how much charge the supercapacitor currently holds. When I connect the multimeter probes to its terminals, it shows just 230 millivolts, which means it's nearly discharged. Next, I'll charge the supercapacitor using a 3.7 volt lithium-ion battery. I carefully connect the positive terminal of the battery to the positive pin of the supercapacitor and the negative terminal to the negative pin. In just a few seconds, the capacitor starts to store the charge due to its fast charging ability. After a short charging period, I disconnect the battery and use the multimeter again to check the voltage. This time, the meter reads 3.5 volts, confirming that the supercapacitor is now charged and ready for testing. Now comes the exciting part, testing the supercapacitor with a 4.8 volt incandescent bulb. I connect the bulb's leads directly to the capacitor's terminals. Instantly, the bulb lights up, showing that the stored energy in the supercapacitor is powerful enough to power a small load. Although the brightness may not last long due to the relatively small energy storage compared to a battery, this experiment clearly demonstrates the basic principle of how a supercapacitor works: rapid charging and quick energy release. This is a fantastic mini project for anyone interested in learning the basics of energy storage components. If you enjoy simple and educational electronics content like this, don't forget to like, share, and subscribe to my channel for more DIY experiments and learning projects.